Hello and welcome back to the course on statistics. Today we've got a very interesting topic, the one-tailed and two-tailed tests. And I gotta say that this is a topic that I personally struggled with quite a lot. Just the way, the intuition behind it, the thinking about it. And what I'm going to convey in this tutorial is my take on it. Like, I'm not an expert in statistics. I'm not the world expert on one-tailed and two-tailed tests. But I have done thorough research into this to help me better understand what's going on. And so I'm going to share with you my understanding of the intuition behind these things and why they're different and how this all works. And then I'll direct you at a very interesting article I found about one-tailed and two-tailed tests, and you can read more there, and that will help you form your own vision if you think that it might be a bit different to mine. So let's have a look. Here we've got a one-tailed test. So this is the hypothesis testing that we've been doing all along. And even though that we haven't been explicitly specifying that it's a one-tailed test, that's essentially what we've been doing. We've been stating a null hypothesis, which was usually something along the lines of the number of households with iPads used to be this, has it increased or has it decreased? And so in those cases, the null hypothesis would be no, it has not increased. So what we're seeing here, no, the null hypothesis, no, the number of households with iPads has not increased. So mu is less than or equal to, I don't know, let's say 80%, whatever it was. And the alternative hypothesis, yes, it has increased. And then we would just see where our sample falls into the sampling distribution. And if it falls in the rejection region, we reject the null hypothesis. Same thing on the left, we'd do the same. If it was a left-tailed test. So if we were looking at the kind of the opposite scenario, if it was decreasing. Now, what a two-tailed test is when you want to check if the number of people or number of households with iPads hasn't necessarily increased or decreased. You want to just check if it's changed. You want to see if over time or whatever other effects or whatever marketing was happening, if something had an effect that changed the underlying parameter in the population. So you want to, in this case, you want to see, all right, so the number of number of households with iPads was 80%. Now we want to see if it's changed. If it could be greater or it could be less. And that's a two-tailed test. And so the essential thing, and this is what I was always struggling with, the essential thing to think is that, oh, well, if I can prove that the number of households with iPads has increased, then obviously it has changed. So it should be easier for me to run a two-tailed test than a one-tailed test, because ultimately I have two options. I can just prove that it's increased, or I can prove that it's decreased, and therefore it's just going to be easier for me. It's going to be twice as easy for me to prove the two-tailed test or reject the null hypothesis in a two-tailed test than in a one-tailed test. However, as it turns out, that's not the case. In statistics, it's actually harder to prove a two-tailed test. So what you do in a two-tailed test is actually you take your statistical significance of 5% and you have to split it between the two tails. So you only get 2.5% here and you only get 2.5% here. And so it turns out that now when you do your calculations and you pick your sample from your population, and then you find out where that mean of the sample falls. It might fall here or here. Now it's much harder for you to reject the null hypothesis because the mean might fall right over here, right next to it. It might fall in the 4% band. And in the one-tailed test, you would have rejected the null hypothesis. But in a two-tailed test, you don't get to reject the null hypothesis because you need the mean to fall in the 2.5% band. And so the main question of today's tutorial is, why does it work like that? Why is it so counterintuitive that a two-tailed test is actually stricter than a one-tailed test? So let's have a look here. We're going to try and understand this based on a real example, like something that could happen in the real world. And that should hopefully clear things up. Let's say we are producing a drug that helps people increase their attention span. So let's say on average in the world population, the attention span is about 40 minutes. And I'm not sure if probably these numbers are incorrect because I'm just making them up, but let's just say for argument's sake that on average, a person has an attention span of about 40 minutes. with a standard deviation in our population of about 20 minutes. So those are our parameters of our population. And so when we plot these sampling distributions, they will have a 40-minute mean, but their standard deviation won't be 20 minutes, of course, because it will depend on the sample size. So let's say we want to test, does this drug increase, we specifically designed this drug to increase the attention span of people, and we want to test if it's working. We want to see if it's increasing the attention span of people. And so we have a sample of, let's say, 100 people, and we want to see if the drug has increased, is increasing the attention span. And so in our case, and in that sample, we got a mean of 45 minutes for the attention span. So in our case, the sampling distribution will have a mean of 40 minutes, just as the population. The standard deviation will be 20 divided by square root of 100, so 20 divided by 10 is 2, the standard deviation here. And we know that the value that we've measured in our sample is 45, so it falls somewhere right here on the right. And so the question is, can we reject the null hypothesis? The null hypothesis is that no, in the one-tailed test, no, and so the mean of the population, assuming that the drug has no effect, if all the people in the world would take this drug and it would have no effect, then the mean of the population would still stay as it is. It would still stay at 40. So, but in our case, because of one-tailed test, we say it's less than or equal to 40, and the standard deviation, and that's it. And the alternative hypothesis is that no, it's increased. And so in that case, we just need to prove that, we just need to check if it falls into this rejection region. But the question there is, what's to say that our drug actually have a beneficial effect on attention span? What if our drug actually does the opposite? What if our drug decreases the attention span? There is no law of physics that would suggest that that is not possible. There is no 100% proof that this drug cannot actually reduce attention span. And that's what a two-tailed test actually also checks for. Actually also implies that in cases when you cannot state with, and this is again how I understand it, in cases where you cannot state with absolute confidence that the effect has to be on one side of the spectrum, you need to test for a two-tailed test, because what could have happened is actually your drug is not just increasing, but it could also be decreasing the attention span. And so that's what you need to be checking for in that case. And so only situations where, in my opinion, only situations where you should do a one-tailed test is where you can justify that it has to be a one-tailed test, that it's not an option for the effect to be in the other direction. And that's when you do a one-tailed test. In the case when you're not sure about that, it's just safer to go with a two-tailed test. And hopefully that makes it a bit clearer why a two-tailed test is harder to prove than a one-tailed test. And that's because in a one-tailed test, you're kind of assuming that you have prior knowledge. You're kind of assuming that this is not even possible, that this is not even an option, that you just want to check that this is happening. In a two-tailed test, you don't have that knowledge, or you're not allowing yourself to kind of make that assumption, and therefore you have to deal with both sides of the tail. So again, this is it's a bit of a counterintuitive topic, but at the same time, it's a very gray area that, as you can see, it's easier to prove a one-tailed test, and so researchers can be prone to actually doing a one-tailed test just to get that p-value and to get the research published and to get the research correct. I'm not saying that all researchers do this, but it can be a problem. It can be a temptation to do that. But it's also always important to look at what's going on, what's actually going on, what do you need to be testing, and what kind of pre-existing knowledge and assumptions can you have and can you make. And we'll see an example of this in the next tutorial when we're looking at an actual analytics challenge. But for now, if you'd like to read more on this topic, I would like to direct you to this blog. It's called One-Tailed versus Two-Tailed Tests. Does it matter? It's by Alex Birkett. Here's a link. You will notice that it is for advertising. It's for ads, on digital ads and stuff like that. But at the same time, all those same concepts can apply to any type of problem. It's just an interesting read, and why I like it is because Alex actually interviewed quite a lot of specialists in the area and got their opinions, and there's a lot of opinions there. So in this tutorial, you just got my opinion. Have a look there, and you'll find many more opinions, and hopefully that'll help you develop your own understanding of one-tailed and two-tailed tests. Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.